Hello, my name is Daniel Presses, and this is the midterm project that I have done for the Game Engine Design and Implementation midterm project. Let's get started. So this is the title screen of the game. This is one of the 3 scenes that are part of the game. The start button will take you to the play scene, where the actual maze is. The show player stats will bring you to the end scene where you can see statistics. And it can bring you back to the main menu, and obviously the quit button would quit you out of the game. Without further ado, let's get started. The game drops you in one of 4 random locations on the map. As you can see, there are moving walls. There's a timer at the top. You can jump around, move around. Explore a little bit. Oh, some more moving walls over there. Some more moving walls over here. And these are a little trigger. If you step on any of these, the floor will actually collapse from under the entire maze, and you will fall to your death. And you will respawn in the nearest spawn location. If you don't think you had a good run, you can press R and reset to one of the 4 random locations on the map if you don't like the spot you started in. Just jump over that turbines there, try not to die this time. Jump over these ones as well. The way you know that you're getting closer to the exit is that the obstacles get harder, so you can see there's more rows of these. And there's more walls. And now there's a combination of walls and trigger traps. Oh, barely made it there. There's a timer at the top showing you the number of minutes, seconds, and milliseconds you've spent on the level. And this gets stored in a special format that I will show later when we save and load the statistics. Let's jump over these. Try not to trigger these ones. Oh. And it's a dead end. And there's the exit over there. Oh no! Oh, I almost fell there. And once you hit the exit, you get a summary of the amount of time you spent to get to each checkpoint. The checkpoints are procedurally generated based on the level map, as is the rest of the level. As you can see from this image right here. All the black lines here are the walls. All these purple dots on the walls are the actual moving walls. All these orange squares that you see in areas here are the pitfalls that trigger the floor to break out. All these red spots over here are the 4 possible spawn locations. The green dots are all the checkpoints. And the blue dot over here is the exit. So another thing about the level is that it is procedurally generated based on this map. So, for example, if I were to change something here, say I close off this wall, and close off right over here, so that this is a dead end, nothing can get in here. If I were to save it, go back into the game, and using a little debug camera, we can see it better. But we can see right over here that it's completely blocked off, right along with the changes I made. Okay? And if we were to go back to the map, undo those changes, save it again, and rerun the game, you can see that the walls that were there were gone. As for the code behind everything, so for the start scene it's very simple, just a bunch of buttons that all are assigned with this scene changer. The start button will take you to the play scene. The show player stats will take you to the end scene. The quit button will quit the application. And if we can see over here, like I said, if it goes into the play scene, it will actually lock the cursor. and otherwise it will unlock it and change the scene. And then if we want to quit the app, it will quit. The end scene is almost as simple. We have a lot of headers, some titles, and then these labels all get updated based on this stats file that exists right here. Whenever you load into this scene, this stats file gets read, and if there's any information, it will show up here. Reset stats will reset the file so that there's nothing in it, and back to menu will take you back to the start menu. If we go to our time label updater, it's just a list of text meshes. They all get updated based on the time that was loaded in after the file, and then we can reset it. And if there's nothing to actually show, then we just reset them to 0. The play scene is where most of the magic happens. So as I said, the actual level has a level generator that does things based on an image. My biggest reference is actually Brachy's for this one. And it takes in an image, it takes in a floor plane that it changes, and the depth plane that it changes. The floor plane and the depth plane will actually resize themselves and position themselves based on the actual dimensions of the image. So if you were to make the image bigger, the depth plane and the floor plane would also get bigger. Then we have some color mappings, which is just a simple mapping from color to prefab to make it easier to list things in the editor. And when we instantiate the level, we loop through the entire image, and if we find a color based on the list here in the editor, then we instantiate that at the position and that the image dictates. We also put a unique identifier to it so we can refer to it later if we really need to, so we don't have just clones everywhere. Every object in the level that is worth mentioning has an object tags. This is how we check for which objects we are colliding with a lot of the time. These are resizable. You can have as many as you want, really, from all of these ones, defined, of course, in a CS file. Our player is just a simple capsule with a camera attached to it. He has a capsule collider, a rigid body, and a player controller script. You can control his actual movement speed, rotation speed, and his jump height through the editor. And we have a main and a debug camera. All of the movement is here. And then this is just checking for collisions between walls and floors and such. Something else worth mentioning is the time label up here, which is controlled by this time controller. And if we go into the time update script, we can actually see it here. This time struct is a special struct that we made just to make things look prettier everywhere else when we report checkpoints and everything. But internally, it's mostly just floats. We reset the time every time we start the level, and every tick we just update this timer. And then I will save the stats logger for the second video. Thank you for watching. This was the Unity side of the midterm project. I'm Daniel Presses. Thank you very much.